Right, we are going to crack on. Remember what I said, NFC, no food comas, as we introduce our next keynote speaker to the Agora stage. We are very honored to have him here. He is the head of AI at Microsoft for startups. My dear friends, please join me in welcoming Rob Ferguson. Thank you.
Hi there, I'm Rob Ferguson, and for the past 5 years, I've been helping the world's best startups redefine AI at hyperscale. I started studying AI about 20 years ago, and it was the least popular thing you could study at university. And then I went on to build AI systems for millions of users and help the top YC startups get all the way through exit and help guide a few AI unicorns. Then my job shifted, and I started working at Amazon Web Services as the global head of AI. And there we worked with the first startups to really go through and help build the next generation of frontier models and define what that was going to look like. And now I'm so fortunate that I get to have the same job at Microsoft, where we look even forward to the next generation, where multi-models is just a part of the future. So I used to say that I worked for the cloud. Clouds are amazing, and the concept of the cloud is amazing. Basically, the cloud makes networks invisible, storage unlimited, and it brings your users within the shortest possible distance to the actual infrastructure that's running your applications. But for the first time, we start thinking of ourselves not just as the cloud, but as hyperscalers. And to build these AI models, we actually had to flip that on its head. Instead of ubiquitous compute that you could use anywhere, we take really precious compute, and we build these compute islands. And these islands have to be interconnected with networks that can work at light speed, where the shortest distances matter, and you have to be able to pull together thousands of computers at the same time in order to be able to train these next levels of models. And unlike CPUs, GPUs actually don't really have the concept of health checks or node swaps in mind. So you really have to expand the concept of what does it mean to work in the cloud. In fact, I'm no longer thinking about what is the next reserved instance going to look like, but I think about, are we going to start reserving agents? Will you have long-running processes where all the infrastructure that goes behind it is a single dedicated coworker? And so as we imagine the next generation of what is the cloud, how these things come together, I truly believe that startups are going to be an incredible, important part of how the next generation of infrastructure is built and how we deliver applications. So I present for you my 3 Horizons Gen AI framework to sort of help you understand everything that I've seen. A lot of people have this question of what is agents? If I asked everybody here to raise your hand and say, oh, what do you think an agent is? I'd probably get 100 different answers. Some people think, oh, agents are just a chatbot, or oh, it's Clippy on the side of my application, or it's a workflow, it's a long-running process. You can kind of imagine that there's a really diverse opinion of what that means. But the reality is, irrespective of the end application of how you build this, the same infrastructure is involved in each case. And in each case, you kind of need to understand the context of what it is those things can do and how they deliver it to build the best applications. So right now, I say we're in this era of custom copilots. And copilots are amazing. They help you translate into any language, automate repetitive code tasks, explore capabilities of the latest and greatest models, build things for disabled people from the jump in any country, in any language, even help you jumpstart a new idea from a blank page. But of course, these copilots have limitations. Sometimes they hallucinate, and if you have a business-critical task, you really need to know for sure that it's going to deliver what it says it's going to. And this is often where we see the trouble with copilots as we know them today. But from my work working with hundreds and hundreds of startups, I've started to see what I would call the next generation. And these are Gen AI native applications. And the big difference between a Gen AI native and a custom copilot is that Gen AI native applications do what they say they're going to do. And it's not much more complicated than that. The best applications, they limit the context of which they're working, and then they understand the data that is part of that application. And they build user trust in non-deterministic situations. Basically, they've seen enough repetitions, they understand sort of the cohort of activities that is on their responsibility to do. And by using real production data and by verifying over and over that they are tuned to the task at hand, they're able to deliver with confidence. And so you see, as abilities and trust keep going, you get to these incredible applications of what's out there, irrespective of if it's a SaaS app, an agent, however you're working, even locally. It's once you have that confidence that the AI is going to do what it says it's going to do, that you have a truly Gen AI native application. And only then do you get to the next horizon that I think everybody's so excited about, and those are the Gen AI systems. And Gen AI systems, what they do is they help you scale value. That's where you have different agents or processes that can work together, and you understand that they're going to work together faithfully. Now, I don't know about you, but I don't want my banking information handed from one agent to another. Yes, I know it's all over the dark web already, but I would prefer that I know the context that these agents are working, that they tell me when they've shared my personal information, that I get an indication. It's like, hey, here's the information that I'm using. I've done this task. Here's how I verified it. And here's the other agents who have had that responsibility. When we look ahead, we can see a number of different areas that are really difficult research problems to understand in this space. How do they adapt this context to one another? How do they build that trust and safety? If you're going to have shared memory, is it going to have my personal information in it? Are you going to be able to plan ahead with the knowledge that there might be new agents coming ahead? It's just like when you have a junior coworker. You want to be a little careful of the instruction that you give to somebody else, because they might run with it. Once you have those things, it still matters that you balance the trade-off of costs and abilities. And one of the most important trends that I've seen throughout all of AI is that all of the best startups are using multiple models. That means perhaps multiple agents. They break it down into smaller tasks. They really need to be able to do so affordably and understandably. I'm still saving up to use GPT 4.5, and I'm not planning on building any applications with it anytime soon. But at $75 an hour or something, I would need to. So you can imagine, you have to break down these tasks to make it successful. And even then, don't you want them to integrate with your old systems? My sister works at the Veterans Hospital, and she still uses a time card in MS-DOS. You need to know that it can work with the system irrespective of how it ages. And that's the value that you see coming forward. My last analogy for you is, in the old days, we used to have a cell phone and a Palm Pilot. Cell phone was good at making calls. The Palm Pilot was good at doing tasks. And then you had like a weird cell phone Palm Pilot that wasn't good at either. And then you had your mobile phones. There's a time period that it takes for convergent technologies to really hit. And so rather than thinking about the application method, is it an agent, is it a SaaS app, how do these things work together, think about how do I build trust and limit context to build the right application for my users. So a lot has been said about Gen AI ops, and I'm sure lots of you have seen really cool architectures that explain how you might go and build your application. I actually really like this one from Insight Partners, and they have done a whole bunch of other ones, and so I really recommend following them online. But of course, the challenge is, as a developer, am I going to have to download every single one of these pieces of technology? Am I going to have to work with every single company in order to build one application? I'm still figuring this out, right? Gen AI is new for everyone. And if I didn't start 20 years ago, I would want to start today. So I'm going to break it down for you a little bit more simply into just 4 categories of how you're going to work with your new coworker. Notice I say Gen AI ops and not LLM ops, because one of the most important things for you to know is that models are getting much, much smaller, and the interaction between models is more and more important. But now that you have multiple models, you're going to need to be able to track them, and you're going to need to be able to understand how those things are working together at a global scale through real production data. So I break it down into just 4 areas. So imagine now I've got everything I used to do to develop software, plus a little bit extra. With Gen AI, all your coworkers, everyone on the team, needs to understand the concepts of confidence, drift, and even more important, what's the data that we're working with, and how is it going to affect the model that we're using? The top question I get asked, more so than any other question, is, Rob, how do I select my model? And what's really important for me is for you to know that the model you're using today is the worst model you're ever going to use. It's the most expensive, it's the stupidest, it's the hardest to work with. Optimizing for the model is probably not the most important task that you're going to be doing. But in order to adapt the model that you are using, it really needs to understand both your users and the data around it. So you want to think about, how am I going to create context? And how am I going to manage this user data? And a lot of times people think, well, I don't know anything about my user. Well, you probably know the language that they came to your homepage on. You probably know that they're here to do the task that you were talking about. Every AI company I work with spends a lot of time creating that context window for the companies that they're working with. Basically, how do I create as best an environment as I can for this model to work? And that's that model adaptation step. So once you understand your data and your users, if I go to a bookstore and I'm in the travel section, there's a good chance I want to talk about travel, right? Understand the situation. Then I move on to the model operations. Unlike traditional applications, within model operations, every single company I work with has an experimentation workflow. I don't have a single company that any of my teams are working with that doesn't consider it an active experiment. And that is pretty different from traditional development. But not only do I have experimentation, but now I have to think about how I deploy. A model deployed on the West Coast of the United States might diverge from one that's in Europe. And I need to understand what is the context and how that happens. I need to be able to monitor that information over time with the model version that's there. And so this model operations really is about understanding what resources does the model affect. Once I have that, I get into optimization. And by far the biggest question that comes there is, the model's too slow. This is taking too long. My users are getting really frustrated. Latency, bar none, affects the way that people develop applications. But if you simply wait, the models seem to get a little faster, right? Yes, but this is where multiple models often comes in. People will break down the task into smaller tasks. For example, translating speech on the mobile device, so you don't have to send it across the network. These are activities you can do reliably. If you can break down your problem into smaller, knowable components, you're much likely to achieve success. And then once you have your optimized model, of course, there's many, many requirements for understanding how you're going to do so in a compliant way in an enterprise environment. So just think of all these things as, here are the tasks to be done, the categories of tasks when working with the model. So in this one example, I'll show you how to adapt for a model. And it starts by understanding the needs and context for data by analyzing and integrating data. So you can ask yourself, what is my data? And sometimes you don't have a lot of data, right? You simply know the context of your application. But the more you can think of data as programming, the better you are programming with models. Then you sort of think about, OK, what are appropriate models that I can use at this moment? I go through this model selection process. I adapt the model to the task. I deploy. And that's when I need to start getting user interaction right away. So the real answer to what model I should be using is, let's focus on getting real user data into our system and creating the loop so that I can do this many times. Hopefully, I can make that process cheaper over time, and I can focus on the 90% of the system, which has nothing to do with the model. It's about understanding how the model's being used in public. And that's the continuous improvement cycle. The reality is that a base model will often be good enough for you to start your task. And maybe you're lucky, you have a generous VC or Microsoft for Startups credits, and you have some time to experiment. You can kind of postpone the model decision until you understand the context of which you're working. Now, the best Gen AI companies are often integrating really tightly to solve difficult problems. I really like Harvey AI. They raised over $300 million, and they took a classic problem that was very difficult for traditional computer science to solve. Basically, they said, how do I search tens of thousands of legal documents and then be able to find the one line of law that I needed using legal speak, which, if it's anything like text speak, is impossible to understand? Well, the answer was that you needed a new kind of technology and also a new framing because the law is interpreted. One person might read it one way, another might read it another. What is the definition of is anyway? Hallucination was a feature for lawyers, and so it was one of the most rapid adoptions of this technology, was in a place where you could say, I could argue it either way, I just want to know relevant context. What a great use for a custom copilot. In my job, I talk with literally hundreds of CEOs, and so what I did is I interviewed a bunch of them and created the next section of this talk based off of how they are currently deploying infrastructure for companies all around the world. We actually have a white paper. It will be available if you go to the Microsoft for Startups LinkedIn, and you can read this whole thing at large. So I really encourage you all to donate it to download the white paper by following us on LinkedIn, and I'll include a QR code at the very end for you all to follow. I was very fortunate to be able to partner with B Capital in this, and we were taught to basically 7 major infrastructure companies after interviewing a few hundred, and some of their responses are here today. So you probably heard of Retrieval augmented generation before, and I like to think about it as a sort of an open book exam for a model. You could either remember everything you had in the exam, or you could go and search for the actual source and then be able to quote it directly in the exam itself. And so really, RAG is kind of you can think of it like search. And it really sort of helps with re-ranking, summarizing, and fusing different data types together. And this really helps build applications because it helps solve the issue with general copilots by grounding the response in your own data, and it bypasses retraining, which is a really expensive step, by just using search. So I kind of like this 101 example of how to think about it, and that's an in-context learning example. So we start off and we say, what are the benefits of using AI in healthcare? And then we search for a document that identifies a document or section that really specifically talks about the information we're interested in. And then we just literally recreate the prompt at the end. And so underneath the hood of your application, the user might have put in one prompt, but we are going to prompt the LLM with, based off of the following document in AI and healthcare, explain the benefits, insert the example that's there, and then now answer the question, what are the benefits of using AI in healthcare? And so to the user, they don't know that we did all those extra prompt steps, that we've extended the window of information to include the document. But now they have the relevant context to make the right answer based off of a search query. I love this example from Ben Clavier. I can provide a link to the presentation online. What he calls minimal viable RAG. And I love because it's like 12 lines of code. And so what he does here is he loads a very simple embeddings model. And if you're not that familiar with embeddings, I want you to think of them as vibes. It's a little bit like a car. It's a little bit like this. It doesn't quite get you to the answer, but it gets you into the direction. And so you go through and you load your embedding model, you download the information that you would like to go see, and then we go through here, we take our query, and then we do a similarity search using cosine vectors and NumPy. But where's the vector database here? Doesn't every Gen AI application need a fancy vector database? That's just NumPy in this example. Why would you need a really complicated vector database if you just had a few search results to search for? You can do it in basically linear time. There's no reason to be adding an extra layer of complexity. We haven't created that requirement yet. So you can simplify it by simply thinking of it as, where is the nearest similarity? One of our Pegasus startups is called Llama Index. Microsoft for Pegasus, if you don't know, is a great place for the world's startups to be able to sell to top enterprises with Microsoft in hand. And I really loved being able to talk to Jerry, the founder. And he said, you know, I think you can get really far with just an embedding model. I don't even think you need GPT. You could go and build a lot of your application simply by understanding the documents that you'll be searching on. And so if I were to take away one lesson, it's you need to match your business context with the model capabilities. If you don't know your business context, then you could be overbuilding and spending a lot of money on something that you don't even have a real use for. What if it is just a simple search? Vector databases also cause lots of hidden problems. It's like having 2 ice cream cones. Now I have 2 copies of my data, and I have to somehow keep up with both of them. I've effectively doubled my problem. And of course, the scaling law dictates that now it's going to become the bottleneck of my system. And then whatever auth and access tokens I have to figure out how to keep that data safe. Vectara is another really interesting company. And I sort of talk about it as the great crisis of data in 2024. It's when you realize that in the old days of keyword search, you would search for the onboarding doc, and if there wasn't an onboarding doc, you get nothing. But now that we have vector search, well, onboarding's right next to offboarding, and so here's the information about the layoffs. The last thing you want is for your system to explode with all this other information that you didn't really want directly into the query. You need to understand that. And so Amr, the CEO, said you kind of want to think of this as the Home Depot versus the IKEA developer. The Home Depot developer is going to describe everything. He's going to grab the wood, the saw, the glue, and everything else to put this application together and be very descriptive about what he needs. And the IKEA developer is just going to use frameworks to help navigate some of these problems. By adopting frameworks, and definitely open source frameworks, we've seen developer after developer be able to save some of these pitfalls by using existing information so that you can get it for the right person, for the right use case, at the right time. Now, there are many problems with RAG. We often see people struggle with how am I going to handle knowledge updates? What external knowledge would I want to incorporate? How do I prepare the data? How do I map this data surface? What are my data surfaces? What are compute resources? And it can still hallucinate after all of that. And so you absolutely have to incorporate real production data. CEO of Ragus, which is another great open source framework, said he calls this production-driven development. From the beginning, you need to be consistent, relevant, and safe responses. And you need to have metrics for all 3 of those as you're developing your applications. We also had the opportunity to speak with Dawe of Contextual AI. They just went GA, and I really encourage you all to go check out their product. He's the original author of the RAG paper. Of course, there were many at the Facebook fair. And he said, actually, you could use machine learning from the system end to end. You don't need to simply think of these as frozen components. You could have your system learn which data is more relevant for you the entire time and continue to adapt it, building a contextual basis for your application. He actually calls most people's implementation of RAG Frankenstein's monster because he says, oh, well, you're using a vector database and embeddings that you never retrain. How do you know that all these frozen components are going to keep working over time? Why not build a continuous system? And he says, it's just 10 to 20% of your system is the model. The rest is understanding things like ingesting, embedding, retrieving, and how to coordinate these large catalogs of information and to understand what data is the most relevant. So what comes next after all of that? Well, you already know, applications. When you go to Bing and you search for the weather, it doesn't return a document about the weather. It gives you the weather. You can tell what time I wrote this presentation, by the way, in Alameda, California, because it's right there. The reality is that you want to understand that custom UI and other components can bypass these other steps to make sure that you're getting the right context right away if you could simply do it in an API call. So you want to serve rich components. Don't ask to summarize the data, just summarize it. And of course, the best practices are still loading. One of my favorite papers showed that if you ask math questions to a language model in the voice of Jean-Luc Picard, you will get more accurate math answers. Stardate, Captain's Log 5.0, what's 5 times 5, will be more accurate. So I guess people who like Star Trek are good at math is maybe a good takeaway. But either way, you need to work with startups, and you need to work with companies who are thinking about these problems all the time. Break it down into components for successful applications to understand the best practices as they come. Because it's all about balancing trade-offs. Nobody likes a super hot laptop in their lap. You need to be able to balance the capabilities, latency, and the user-driven context in order to become Gen AI native. So thank you very much for all the CEOs who helped me with this presentation. I would definitely love to thank each of them individually and for you to download the white paper by following us on LinkedIn. If you like credits to build your own startup, please go to our website at Microsoft for Startups. You can qualify for up to 150K of startups, get access to tools like GitHub, M365, and LinkedIn Premium, as well as access to the latest models. Thank you all so much.